Hello and welcome to this video. Please, before we can even discuss further on the VSEPR model, we would like you to subscribe to our YouTube channel, Zulua Consultants, and the Facebook page, Zulua Consultants, so that you can enjoy this and more videos. Please, again, don't forget to click the notification button and the notification bell. So let's see what we have in this video. What is the VSEPR model? Well, this is basically the valence shell electron pair repulsion model, which makes an assumption that electron pairs repel one another. Now, this model, we highly use it to come up with the molecular geometries of molecules. So far, if you are learning chemical bonding, you have come up with the knowledge on how to draw the Lewis structures, how to calculate the formal charges. Now, with this model, it helps us to know the molecular geometries of those structures you have been drawing. So let's see how this model helps us. First of all, let's discuss what these repulsions are all about. Under this model, the three types of electron repulsions are: the first one, the lone pair to lone pair repulsion, the lone pair to bonded pair repulsion, and the bonded pair to bonded pair repulsion. So all these repulsions result in different influence when it comes to the geometry of the molecules. Now, as you can see, it is already showing that the repulsion between the lone pair and the lone pairs is greater than the repulsion between a lone pair and a bonded pair. And in turn, this is greater than the repulsion between the bonded pair and the bonded pair. So what does this simply mean? The influence these repulsions have when you have two lone pairs, it is greater than when you have one lone pair and bonded pairs, or when you have all bonded pairs. So as we'll be discussing these geometric shapes, we should remember that these repulsions have different influences. Hence, even if the pairs of electrons might be equal, if you have two lone pairs, or if you have one lone pair, or if all of them are bonded pairs, the influence and the resulting geometry will be different. So let's see what is the limitation of this model we are talking about. The VSEPR theory, or this model, has some limitations. And in this video, we are going to look at three limitations that this theory has. The first limitation is that it fails to explain the isoelectronic species. Now, what are isoelectronic species? Well, this basically are elements having the same number of electrons, or ions having the same number of electrons. So this theory fails to predict correctly the shape that such elements or ions should have. If you want to really know more about the isoelectronic species, you can watch one of my videos that has explained this concept fully. So this is the first limitation of this theory. It fails to explain the isoelectronic species. The second limitation of this theory is that it fails to explain fully the shapes of compounds formed with metals that are transition metals. Now, this is fully because of the two factors. The first one is this theory does not take into account the associated sizes of subsequent groups. Then the second one is this theory does not take into account the lone pairs that are inactive. So because of these two factors, this theory cannot be used to predict compounds with metals under transition methods. The third limitation that we'll talk about in this video is that this theory fails to predict correctly the geometry of the compound formed between group 2 elements and halogens. Now, this theory, when that structure is drawn, this theory predicts that such a geometry should be linear. But in the actual sense, when you look at that shape, it is a bent shape. So this theory predicts that it's a linear, but the actual shape is a bent one. So this is another limitation that the theory has, and it fails to predict this correctly. So having known these three limitations, we are now equipped to look at the steps we should take to come up with the geometries. So in the next video I'll be doing, and in the video that you'll find in this channel, Zuluba Consultants, we will look at now the steps which you can take to come up with the geometries. Please don't forget to subscribe to our YouTube channel, Zuluba Consultants, and the Facebook page for this and more